Hey, I'm Jake. You can find me on the Atmosphere or on normal DNS at jakelazaroff.com. I talk a lot about web development, local first software, and most recently ATProto. But before we, this is the speaker notes are here. Oopsies. Is there? All right, I can try to do this without these things. All right. Anyway, I have a vendetta that I want to talk about here. I'm an app view hater. I mean, I realize that they're useful for aggregating your graphs of follows or whatever. I can't promise you'll never see me make one, but they raise the complexity of an application significantly. If you're just making requests to your PDS, you can have a static site that you just deploy to any web server, probably for free. But once you have an app view, you start needing to do a bunch of DevOps stuff. Like you need a database, you need monitoring, you need backups. You probably have to pay a monthly fee. So I've been doing a bunch of experiments on ATProto, how to build cool stuff without an app view, just as a PDF. And the one I want to talk about is ATProtoCall. Oh my goodness, the little video is not playing. All right, I'm not going to try and troubleshoot Google Docs or Google Drive here, but basically it's a video chat app where there's no signaling infrastructure at all. It's just static files in ATProto, and you type in someone's handle, and they get a little notification like jakelazaroff.com is calling you, and you can pick up, and then you see their image, your image, you talk, you chat, and yeah, it uses WebRTC, so it's peer-to-peer, and usually that requires servers, the things that I'm saying that I hate. And so I'm gonna go over how that usually fits together and how I did it here. So we can start. We'll say Alice and Bob want to communicate with each other. No, I don't have the permission. And then, so usually what happens is there's something called the signaling server. It's usually a WebSocket server that it's known entity to both of them. They connect to it. They can send messages. It will proxy those messages to each other. Alice is I want to connect to Bob. It gets to Bob, and Bob can respond. And that kind of brokers the connection, but that's insufficient for them to actually connect to each other peer-to-peer. Because usually when you have a computer, this little dotted line is your local network, and your local IP address. You know how to reach yourself locally, but you don't know your public IP address. You don't know how other people reach you, or ports and stuff. So there's a protocol called stun, and it's not super complicated. You have this server called a stun server, and you send it a packet just saying hi. And that packet contains information about how to find you. It's like a return address, kind of. And then that stun server will respond back with exactly what it saw there. That's called a candidate. And that's how that's how you know your public address. And these stun servers are totally commoditized. Google runs some, Mozilla runs some, Cloudflare probably. You can just kind of show up and shoot packets at them, and they'll respond. So this is sort of the high level overview of the infrastructure. We have our two people, we have the signaling server, and we have the stun server. So to start the connection, first Alice will start stunning. She'll send the packets to the server. We'll come back with her candidates, and then she will send them over to Bob. This is where you'd get some sort of UI Alice is trying to connect to you. Bob then stuns. He figures out his own candidates, sends them back to Alice, and then they start sending packets to each other, and eventually you make a peer-to-peer connection. And the key to ATProtoCall is that the signaling server is not actually part of WebRTC, the spec. It's totally out of band. it doesn't care whether you use a WebSocket server to exchange these candidates, or SMS or a QR code, or like passing a note in the back of the class to your crush, except instead of "do you like me" in a yes or no checkbox, it just has a bunch of IP addresses. Like, all of that is kosher. And so what I've been doing with ATProtoCall is basically just abusing ATProto as this sort of ersatz signaling server. What are the primitives we have in ATProto? We have the PDS, and we have the relay, and then like the jet stream, which is the thing that you can connect to in the browser that pushes stuff to you. So here, how it works is, first Alice will still sun. She needs to find out how to find herself on the internet. And then she will write a special record to her PDS that contains her candidates and Bob's did, which she has the handle, she can resolve it. And maybe I should say like alice.com and bob.com. And then the PDS will push that over to the relay and the jet stream. And then Bob is subscribing to updates, and he can filter out any dids that he doesn't recognize. And then, so when he gets to his own did, he sees, okay, Alice is trying to connect to me. These are her candidates. And then Bob will go and stun. He'll push a record to his PDS. It goes over Jetstream. Alice does the same sort of filtering process. And at the end of that, they have each other's candidates, and they can connect peer-to-peer. And that's kind of it. There's very little secret sauce here. The big caveat to all this is that it's all in the open, right? You're writing these records in your PDS. We don't have private data right now, so any police investigators, wizards can just inspect the jet stream and see, like, all right, Alice is trying to connect to Bob, and also this is both of their IP addresses. So that's not great. So really, I think, like, to feel comfortable productionizing this, we need a good private data story. So hopefully that's coming in a way that's amenable to this sort of, push peer-to-peer communication. But actually, I'm not even like that excited about video chatting. Like, WebRTC has this feature called data channels where you can just send arbitrary messages between peers. So this is, if you look way up at the top there, I made a real-time collaborative text editor, also in ATProto, also with no servers, using a CRDT library called YJS. And CRDTs are, it's a little long to get into, but they're this like network transparent data structure where you can send updates also out of band, however, over any sort of channel. And then when everyone gathers all the updates, they will, you can merge them and you'll have the same document. So it uses ATProto to push these updates between peers, and it turns out they can collaborate pretty close to real time. The downside is that, at least in the reference PDS, there's like these rate limits where you can only make a few thousand requests per second. So if you're sending one for every character that you type, you go through that pretty quickly. So this is only close to real time, but you could actually use WebRTC with this ATProto peer-to-peer like brokering method to actually make this a real-time collaborative document editor that uses no infrastructure that you maintain at all, just the PDS and the Jetstream. So that kind of brings me to what I actually want to talk about, which is local first software. Definitions abound about what isn't local or what is local first. But if you're not familiar, it's this like movement where the data that is on your local computer is the most important. So this is a slide from, I took it from Martin Kleppmann's keynote at a recent local first conf, or the second most recent, so if it's local only, like if you're not sending updates over the network, it's not local first. That makes sense. If it doesn't work with the Wi-Fi off, it's not local first. You need to have some sort of offline access. And then also, if it doesn't work, if the app developers go out of business and shut down their servers, it's not local first. And I feel like that point specifically should look like pretty familiar to anyone who's sort of enmeshed in the ATProto community, because it reminds me a lot of credible exit, right? Like the idea that even if, Blue Sky or Tangled or Leaflet or whatever, if it like goes out of business or they decide to turn evil or anything, you still have your data. You can do whatever you want with it. Like, you have control and ownership. But I think actually the overlap goes even deeper than that. So this is a snippet from a paper by the research lab Ink and Switch on like a case study they made about building local first software with servers. And they say, I'll read it a bit. They say that the cross-device data synchronization mechanism should depend on servers to the least degree possible. And where servers are used, we want them to be as simple, generic, and fungible as possible, so that one unavailable server can easily be replaced by another. And then they shouldn't be centralized. Any user or organization should be able to provide servers to serve their needs. And for a while, I thought that this was like, you have a server, you open source it so that when you go away, anyone else can like spin up the server and still use your app. But I think that is maybe like a little, like no one wants to do that. And I think ATProto is sort of this fungible generic server network that we are, we're starting to build. Like, we have, everyone has a PDS that can do mostly the same things. We have this jet stream that just kind of shuttles like notifications of like updates. And then we're starting to build a network resiliency, right? Like, we saw like Blue Sky had a bunch of downtime a few weeks ago, but people were able to use Black Sky to access the network. We were like able to step in. And then we have Microcosm, which is building this whole set of like community hosted infrastructure that is available for anyone to use. And so I feel like this is, this network will let us build this sort of software that gives us ownership without making every app developer an island that needs to host their own infrastructure and be responsible for maintaining it. And that's basically it. I mean, I made these things because I think that what we can do a lot more with like ATProto than we're seeing right now. Like, I care about local first software, but you might care about, we could make like multiplayer games or notification services. Like, we have these like very general primitives, this like pub sub, these little pub sub pieces of infrastructure, and yeah, we can do a lot with them. So yeah, sky's the limit. Thank you.
Thank you.